Well, hello people. It's time. The audio video looks fine to me. I can hear myself. And if one of you can confirm that both the audio and the video is going out fine, then we can continue with what we have been discussing so far. Right? So, good afternoon, everybody. Let me just write it on the screen. Good afternoon, people. Can you hear / see me? I hope there are no technical issues from my end, because even if one person confirms that both the audio and the video is going out fine, then that means there's no issue from my end. And if somebody is not able to hear or see, it is something from their end. So I have a few people I can see, they are live. I want one of you to confirm whether you can see and hear me. Hi Akshat, good afternoon. Looks like it's fine, since I've got a message that only tells that everything is fine. Hello Suyok, looks like you were not there yesterday. That's fine. Also, I've been advised to not really be loud while teaching. I think a lot of you on day 9 or day 10, you would have seen my musical session. So I am a musician and I'm quite serious about pursuing it. Hello Ryan, good afternoon. And for a singer, it's not advisable to put any strain on his or her throat. And I discussed it during my vocal training to my teacher that I think teaching is affecting my singing, because I'm putting a lot of strain on my voice while speaking in order to make sure that the class is enthusiastic and attentive. That's a natural thing which happens. But from now on, I will try to. Good afternoon, Udit. From now on, I will try to consciously keep that in mind, that I do not have to get loud. But at the same time, I will try to make sure that the class doesn't get boring through interesting concepts. Anyways, today is the 14th day of this bridge course, which means we have completed 2 weeks now. And in these 2 weeks, we have finished so much. If you see, we have finished. We started with units, we covered dimensions. From dimensions, we went to, what was the next thing? Error analysis. Error analysis itself was made up of many things. It had calculation and identification of a lot of errors, causes of errors, combination of errors, so many things, right? After analysis, error analysis, we went to vernier calipers. We started with instruments. Then we did micrometer screw gauge. These together, I had put them into instruments. And then we have started with vectors. We have seen what vector is, how it's represented, right? Why do we have to study it? And then, the concept of magnitude and direction, how do you represent it using theta and the length of the vector? Then we saw some properties. Then we saw types of vectors. And then after that, we have started with the operations on vectors. And to cover all of this, it has taken us 14 days, and I have only taken 1 hour per day. It's not that we've been having 2 hours classes, right? So as you can see, even though I'm going very slow, I don't have the need to repeat things, which is why we are able to every day cover something and we are moving forward. And that's because we don't have the need to repeat things. First of all, every video is put once the lecture is recorded, it's put online on this channel. It's there for you to watch. That is one reason. And the second is we are covering it so slowly and so much on the fundamentals that it hardly requires any repetition. I think everybody who's joining in is understanding. I'm at least assuming that from my end. And if somebody differs from that, they can very conveniently put that in the chat, right? But the thing is, as I've told you, this is just 30% of stuff. 60 to 70% has to come from you, which is your practice. This is 30 to 40%. So this is a teacher's job, and this is your job. And even if this falls in place, if this doesn't fall in place, you will still not be able to do problems on your own. We have done a half-an-hour session on understanding why this is true. So you can go back a couple of lectures back and you can watch why these numbers are true. Okay. Well, Akshat asks, sir, when will you post the 5-minute intro of the bridge course on YouTube? I will do that soon. In fact, I plan to record it in a couple of days, today or tomorrow. By the end of this week, it will be there. Okay. As I've already told a few people, I have my own YouTube channel. It's called Salap Swarnim CR. Please do check it out. And the video that Akshat is talking about, the intro video, I will put that video on this channel. And from here, you can forward that to all your contacts who would possibly be interested to be a part of this bridge course. And since it's for free, I don't think anybody should have any problems. A lot of times what happens is, people, if something comes for free, they feel that it's not of that high quality. I have clarified that beforehand, that just because this course is free, it doesn't mean that it lacks in terms of clarity. It is free because of the fact that we want to do something for the students at this point of time. It's not that all the courses that I'm going to do in the future, all the teaching that I'm going to do in the future is going to be for free. That's not going to happen. Right now, because of the pandemic and stuff like that, we have launched this. So, and I guess everybody who's a part of this series, you guys must be feeling yourself, right? It's not that the course lacks in terms of clarity or quality. So you can convey the same to your contacts when you forward them this 5-minute video that Akshat is talking about. It will be on this channel pretty soon. I will record it in a couple of days and it will be there on my channel by the end of this week. Once it's there, I will put it in the live class also. And if you subscribe to my channel on, in fact, also press the notification. Subscribing itself is not enough because you might subscribe a lot of things. But if a video is put on a channel that you are interested in, you will never know unless you press the bell icon. That's important. Okay. So with this, we are good to go. Good to move forward. Yesterday, we discussed addition of vectors. We saw how that parallelogram law of vectors work. We also did a problem, a slightly intensive problem in terms of calculation. It also had some basic trigonometry to be dealt with, which I told you don't have to worry about right now. Okay. Today I'm going to discuss a few things. Okay. So as you have seen yesterday, if you have two vectors, first vector is a bar, second vector is b bar, and if you know the angle between them, you can find this vector r bar, which will be equal to a bar plus b bar, right? So if you have to add two vectors, then that vector is nothing but the diagonal of that, that diagonal of the parallelogram formed by these two vectors as the edges, which passes through the tail of these two vectors. You have to make sure that the vectors are joined by tail, and then your diagonal which starts from the tail, and it traces the diagonal, that vector. Hello Shreya, looks like you're here for the first time. Welcome. So that diagonal which passes through the tail, and not just passes through the tail, which starts from the tail, that is your vector. It starts from the tail and it is directed towards the diagonal. That is your resultant or the addition vector. I've also told you the formula for this. In fact, we derived the formula properly in yesterday's class using only your 10th class mathematics, right? I did not go any forward. I just used your 10th class mathematics to derive it. And this formula was under root a square plus b square plus 2ab cos theta. Okay. And let's say if you also want the angle that this vector forms with a bar, you can successfully do so by using this formula. Tan of alpha is b sin theta by a plus b cos theta. In fact, you can also get this angle. It's not just with a, you can also get the angle that this vector makes with b, right? I want you to figure out what this beta is going to be, but you don't really need a formula because you know that alpha plus beta is theta, right? So beta is theta minus alpha, and alpha is tan inverse b sin theta by a plus b cos theta. Either you can use this formula, or you can use the same type of derivation that we did to get tan alpha. We constructed a triangle, if you remember. We constructed a triangle, right angle triangle, and then we got tan alpha from that. Instead of constructing a triangle that side, you can construct your triangle in this way. In this way, like this can be your triangle, and this will be 90, right? Will this be your triangle? No, sorry, not this. This will not be your triangle. Your triangle will have to be this. Something like this. From this you can get your tan beta. So you will have to know this length, right? You can use that. But that can get complicated too, right? That can get a little complicated. So instead of that, you can just use this, okay? So we also discussed a numerical based on this. But my question, I would like to ask a question to you. As you can see, this a is a constant, like the length of the vector a is fixed. B is a constant. Let's say your vectors are fixed. Theta is variable. Variable as in, I have two vectors. What is the maximum? What is the maximum that I can get from those two vectors? But what I mean by maximum is, what is the greatest length that I can get by the addition of the two vectors? So I would like to demonstrate this using this diagram. So you have a vector A, you have a vector B. This guy is of length A units. This vector is A bar, and it's of length A units. This vector is B bar and is of length B units. You have these two. You want to combine them, or you want to find the addition of these two, the resultant vector of these two. What is the greatest length that this resultant vector can have? First question. And the second question is, what is the least length that this resultant vector can have? First of all, the way you align A and B decides a lot of things. What I mean by that is, if I have this vector A, if I have this vector B, these two vectors are fixed, but the angle between them is not fixed. This can be anything. This can be anything, right? And the resultant that you get from these two, its length is root a square plus b square plus 2ab cos theta, where a and b are fixed but theta is variable. So if I can get the least value for cos theta, then that will be the least value for r. And if cos theta has an upper bound, which means if my theta is such that cos theta is the greatest, then for that theta, r will be the greatest. So I don't know if you guys know this. Cos theta is a function which lies between -1 and +1, which means you have this function called as cos theta. This theta, no matter what this theta is, whether this theta is 0, whether it's 180, whether it's -260, whether it's -3,340, or whether it's plus 4,09,820, doesn't matter. Doesn't matter what that theta is. Once you put that theta in a cos function, which means cos theta's output, what happens is cos theta is a function. You give various values for theta. When you give theta equal to 0 degrees to this, you get 1 as the output because cos 0 is 1. When you give theta equal to 90 degrees to this function, then this gives me 0 as the output because cos 90 is 0. Likewise, when you give theta equal to 180 degrees to this, then cos 180 is -1. I don't know if you know this or not, but cos 180 is -1, so the output is -1. So, no matter what theta you give, whether you give 1 lakh, theta is equal to 1 lakh degrees, doesn't matter. Your output will always lie between -1 and +1. This is a property. This is a property of the trigonometric function cos theta. Okay. So since cos theta can have a minimum value of -1 and a maximum value of +1, that means r can have a minimum value of, what is the minimum value of r? It is nothing but under root a square plus b square plus 2ab into -1. Because cos theta's minimum value is -1, so it's under root a square plus b square minus 2ab, and you know what this means? This means it's minus a minus b whole square, which is mod a minus b, right? Why am I using the term mod here? Remember, whenever you have this under root x square, never write it as x. No, do not do that. Under root x square is mod x. Okay, you will study this, you will understand this when you study functions and mathematics. That is because if you have a function x, if you have a number x equal to -2, then under root -2 whole square is not -2. It is mod of -2, which is +2. Correct? Your x can be negative also, no? Then that is why you can't do under root x square is equal to x. That's not valid. You have to put the mod here to account for those x's which are negative. That's why this a minus b can be negative also. That's why root a minus b whole square is mod a minus b. Okay. So minimum value for r that you can have is mod a minus b. And what is the maximum value that you can have? To get the maximum value of r, I need the maximum value of cos theta. So under root a square plus b square plus 2ab into 1. Because cos theta's maximum value is 1. It can't be more than 1. Okay. So you have under root a plus b whole square, which is modulus of a plus b. Okay. Making sense? This is how it goes. So for a given pair of vectors, a and b, the maximum that you can achieve from these two is a plus b, mod of a plus b, and the minimum that you can achieve from these two is mod of a minus b, where a and b are the lengths. A and b are the lengths of these two vectors, a bar and b bar. Okay. How do you visualize this? How do you visualize this? You have a vector a, you have a vector b. If this theta is 0 degrees, then how will a and b look like? It will look as if they are along the same line. Like your a is along east. This is your a bar, which has a magnitude a. Okay. Sorry about this. Use small letters for magnitude. Okay. And capital letters with a bar for vectors. Okay. So this a bar has a magnitude a and it's pointing towards east. And if your theta is 0, then b bar also will be along the same line. B bar which has a magnitude small b will also point towards east. If two vectors are pointing along the same direction, I can simply add them. In this case, a bar plus b bar will be a plus b. Okay. So this is the max that you can get. What do I mean by max that you can get? Maximum sum or the greatest length of the resultant vector can be a plus b, right? And if this theta is 180 degrees, a bar, b bar, if the angle between the two vectors theta is 180 degrees, then you know what will happen. Look at the formula. R minimum for theta equal to 180 degree cos 180 is minus 1. So R minimum will be a mod a minus b. Okay. So if your a is less than b, if a is greater than b, then your resultant vector is going to be a vector which points in the direction of a and will have a magnitude a minus b. If your b is greater than a, then the resultant vector of these two is going to be a vector which will point towards b and it will have a magnitude b minus a. Okay. Mod a minus b and mod b minus a are the same thing, right? Because ultimately these two quantities will only differ by the sign, and when you put a mod on the sign, then you will get the same output. Okay. I hope you're understanding. I hope you're able to visualize this. Don't think that when the vectors are along the same line, there is no parallelogram formed. There is a parallelogram formed, but that parallelogram, so when a and b are like this, the parallelogram is like this. Okay. If this theta becomes 0, then b will start coming on a. And when b completely lies along a, that is when the resultant will have the greatest length, and that is a plus b. If b starts going away from a, then parallelogram will start opening up. And when b and a are completely opposite to each other, that is when you will have the least magnitude possible for the resultant vector. Okay. So I hope you understood this concept of greatest length, smallest length, both algebraically and graphically. Okay. I'm only talking about a pair of vectors which are fixed, like your a and b is fixed in terms of magnitude. I'm only changing their direction. I'm only changing their orientation with each other. Okay. That is when, and also, so there are three important cases. Like as far as this formula is concerned, there are three important cases. Case 1 is when theta equal to 0 degrees. We have discussed that. When theta is 0 degrees, then a and b will lead to the greatest resultant, like the resultant with the greatest length, and that is a plus b. Case 2 is when theta equal to 180 degrees, then a and b's resultant will have the smallest possible length, that is a minus b mod with a mod, because we don't know whether a is greater or b is greater. So to be safe, we just put a mod. Okay. There is one more case which is important, and that is theta equal to 90 degrees, which means if these two fellows are at 90 degrees to each other, then what is the length of the resultant? What is this r's length? Well, it's simple actually. If you look at the the general formula for any theta is root a square plus b square plus 2ab cos theta. And here my theta is 90, correct? So cos 90, you know the value. Cos 90 is 0. So 2ab into 0, which is under root a square plus b square. So the length of this resultant is going to be root a square plus b square, which is something that is not new for you, because when a and b are at 90 degree, that means the parallelogram that's formed with a and b is a rectangle, correct? Because theta is 90. And in a rectangle, what is the length of the diagonal? We know the formula already. If this is b, then using Pythagoras theorem, this is just the diagonal is just the hypotenuse, right? So it's simply root a square plus b square. So in fact, you already knew this case, but I just wanted you to visualize this case from the formula's perspective. So all three important cases of the formula we have discussed. Okay, let's look at another law for addition. The most important law for addition is Parallelogram Law of Addition. I'm teaching you another law for addition, which is not very different from Parallelogram Law of Addition. It's not very different. It's called as triangle law. According to triangle law, it's very simple. If the tail of one vector is aligned with the head of another vector, so if the tail of one vector, which is B, is aligned with the head of another vector, which is A, then the resultant of these two is that vector which starts from the tail of the first vector and goes to the head of the second vector. This vector also is the resultant A and B, the A plus B. Okay. Parallelogram law was valid when both vectors were aligned by their tails. They were joined by the tails, and the diagonal which started from the tail, that diagonal was the resultant. Here, two vectors are not aligned by the tail. They are not joined by the tail. They are aligned in such a way that the tail of one vector is aligning with the head of the other vector. And now, the resultant of these two is that vector which starts from the tail and goes to the head. Let me call this vector as C. This resultant vector, instead of R, let me call it as C. Okay. So C bar, which is your A bar plus B bar, is this vector. Okay. Now I also told you that this is not very different from parallelogram law. Why is it not very different from parallelogram law? Let's look at that. From this law itself, I can construct parallelogram law also. So you know that this blue vector, according to triangle law, this blue vector that you see, this blue dotted vector, is the resultant. Okay. So what I will do, let me rub this. Let's say I did not know that this was the resultant. Then I will try to use parallelogram law. For using parallelogram law, what do I have to do? I have to join these two vectors by the tail, which means I need to hold this B and I need to bring it here. So I will construct the vector B here itself. Now tell me, if let's say this red vector is called X, is this X same as B or is it different? X is the same as B. This is B only. Don't think how two B's have come. This guy is also B, this guy is also B, because both of them have the same length and both of them are pointing in the same direction. And I have already told you, like vectors or equal vectors are those vectors whose magnitudes and directions are same. If these two are same, then even if they look away from each other, they are still the very same vectors. So this is also B. So now you have A, you have B. You just have to construct the parallelogram with these two as the edges. So this is your parallelogram law. And now this vector, this blue vector which starts from the tail of A and traces the diagonal, that is the resultant. So did you not notice? Triangle law and parallelogram law gave me the same result. They ultimately mean the same thing. They are only different from each other in terms of representation. When I talk of parallelogram law, I talk of this B and this A. When I talk of triangle law, I talk of this B and this A, right? But this B and this B are both B's, they are same, right? That's why these two laws also are not very different from each other. Okay, so that's all. Could you tell me, if you have this vector B and this is A, which law is suitable to use, triangle law or parallelogram law, even if both of them are the same? Which law is suitable to get the resultant? Yes, the answer is triangle law, because here you have a tail, here you have a head, here you have a tail, here you have a head, and here head and tail are joined. If tail and tail were joined, that's good. Akshat, Sangeeta, pretty good. You guys are understanding. I hope others are understanding too. If these two vectors were joined by the tail, then I would use parallelogram law. But now to get A plus B, instead of parallelogram law, I will use triangle law. What does triangle law say? The vector which starts from the tail of one vector and goes to the head of the other vector, that is the resultant vector, A plus B. Again, do not do the reverse. Do not start the vector from the head and go to tail. This will be wrong. In fact, later you will see that this, in fact, now also you can see this is minus A plus B. This is the negative of A plus B. Because once you multiply a vector with a minus sign, then that vector reverses in terms of direction. Okay? So do not do the reverse. Do not start from head, go to tail. Always start from tail and go to head. Okay? So, triangle law done. Now let's discuss the next operation, next algebraic operation. I know I have started to speed up a little, and that's probably because I have this confidence that you guys have started to understand things now. And now I can afford to start speeding up a little bit. Again, don't worry, I'm not going to start skyrocketing like most of your coaching institute teachers, because they have a push, they have this pressure on their head that they have to finish the syllabus. My pressure is to make sure that you understand stuff, because if you understand these things in detail, then things in the future can be understood even if they are taught fast. All right, so let's go to subtraction now. Subtraction of two vectors. Okay, we have seen addition. Okay, if I have two vectors A and B, then I know how to add them. If they are joined by tail, I can very conveniently use parallelogram law. I can draw the parallelogram. I can take this resultant which starts from the tail. Okay, where is, which color should I use to differentiate this? This vector which starts from the tail, this r bar is A plus B. We have seen this. Okay, but how do you get A minus B? Question is, what is A bar minus B bar? First of all, we know that if I subtract two vectors, I will get another vector. This vector is called as S bar, let's say, subtraction. Like S bar is A bar minus B bar, let's say. Okay. Now this S bar, which is the subtraction vector, what is its magnitude and direction? Even before I start explaining this, I'm going to give you a brownie tip, that this other diagonal that you see, this itself is A bar minus B bar. This diagonal which starts from the tail and goes to the opposite vertex, that is A plus B, and the diagonal which is the second diagonal, that is the subtraction, that is A minus B. But the point is that second diagonal can have two orientations, right? It can either be like this, or it can also be like that. Fine, I know that the magnitude of A minus B is going to be the same. Whether I take this blue vector, whether I take this blue from B to A, or whether I take the blue from A to B, they are both of the same length. So one thing I know that A minus B is going to have the same length as this diagonal has. But length is not just a sufficient criteria for me. I also need the direction. I also need the direction of this A minus B. How do I get the direction? So which of these two blues is correct? 1 or 2? Let me see if somebody already knows this. If you don't worry. I'm going to spend the other half of the class in only explaining this today, and only tomorrow we will start with something else. So does anybody know whether 1 is correct or 2 is correct? Which one should we choose? You have understood my question, right? My question is, the green vector is something that we are clear with. That is the sum of the vectors, A plus B, A bar plus B bar. And I have told you, without giving any reason, but I have told you that the other diagonal of the parallelogram is the A minus B vector. But that diagonal can be from B to A, it can also be from A to B. So the one which is from B to A is 1. The one which is from A to B is 2. And which of these two do you think is the right answer? Whether it's 1 or whether it's 2? No answers coming, so I believe people have absolutely no idea about it. So that's fine. We will discuss it now. It's a very simple procedure, you know, how to do A plus B. Can I write A bar minus B bar as A bar plus of minus B bar? This is something that you can tell me, right? If not anything else. Is this correct? Can I do this? Nothing wrong with it, no? This can be done. So in fact, subtraction in a way is addition only. Or in other words, subtraction in a way is addition of the negative of the second vector. Now, if I have been able to successfully implant the pattern in your head, you would have already thought of how to subtract these two. Because ultimately you are only adding two vectors. You already know how to add two vectors. The only thing is you don't know what this second vector is. So some of you, I think, who have successfully been able to identify the pattern of addition of vectors, you would have deduced the solution on your own. If you haven't, don't worry, we are going to discuss this now. You have a vector A bar, you have another vector B bar. Okay, let me do this on a different page because it's going to take some space. And I want it to take a lot of space because you need to see it clearly. This is A bar, this is B bar, if you want to do A plus B, you construct a parallelogram and you say that this guy is A bar plus B bar. But you want A bar minus B bar, which is your subtraction vector, which is A bar minus B bar, which is A bar plus of minus B bar. Akshat says, sir, we will use triangle law. Perfect, you can do that. You can use triangle law also. You can also use parallelogram law. How will you use that? So this vector, this brown vector, which is to the opposite of B, is itself minus B bar. Blue vector is B bar, brown vector is minus B bar. And now I have to add A bar with this brown vector. This is the brown vector, no, minus B bar. So this A bar and this brown vector have to be added. Now how do you add two vectors? You already know. Right, you know how to add two vectors, don't you? You will only have to construct a parallelogram with these two as the edges. And then this fellow that you see, these two vectors are joined by the tail already. I have to add vector 1, which is minus b, with vector 2, which is a, and these two vectors are joined by tail. So that vector which starts from the tail and traces the diagonal, that is my resultant. And in fact, I should call S, because R bar is something else. So S is nothing but this is your A minus B, A plus of minus B, or A minus B. This is your A minus B. Now tell me one thing. This vector which starts from the tail and goes here, isn't this the same as this? Is there any difference between this guy? This guy is also S only. Why? Because look at their lengths. They are the same. This guy also is of x units. This guy also is of x units. If this guy is pointing towards southwest, if it's not southwest, like I don't know whether it can be anything. It can be any direction. It can be north also. Because you don't know where you're looking from. No. You don't know where your origins are. So no matter, doesn't matter. If it's pointing towards a given direction, then this vector will also point in the same direction. So magnitudes are the same, directions are the same. Why will this be different from this? This guy is also S. So if you have to do A minus B, then you have to choose. Where did that go? Oh, I ended up rubbing it. Remember, I drew two blues, one which started from B and came to A, that was one, and the other which started from A and went to B, that was two. So you have to choose one, okay? You have to choose option 1. What is the difference between parallelogram law and triangle law, sir? Please tell. There is hardly any difference, Sangeeta, as I've told you already when we discussed it. Parallelogram law is used when you have A and B which are joined by the tail, okay? If they are joined by the tail, then you use parallelogram law to get the resultant. Whereas triangle law is used when you have your A like this and your B is like this, like tail and head and tail and head, which means head and tail are joined, but here tail and tail are joined. So head, tail, tail, head. Here tail and tail are joined, here head and tail are joined. When head and tail are joined, then you use triangle law. And then the vector which starts from the tail and goes to head, that is your A plus B. Okay. In fact, in this and I also showed you how these two are similar. Okay. In parallelogram law itself, if you look at this other B, this B, then this B is using triangle law in this part. Okay. So I hope it's clear. You're able to visualize it. So what is the story that we have? I hope you had a conceptual understanding of how we subtract two vectors, right? So here is your vector A, here is your vector B. If you want to add these two, then that is represented using this green vector, R bar equal to A bar plus B bar. If you want to subtract these two, if you want to do A minus B, then you have to start from B and go to A. Let me call this as the brown vector. Start from B, go to A. This is your A minus B vector. What if you have to do B minus A and not A minus B? Then you'll have to start from A and go to B, but you'll have to be along the same second diagonal. This is your B minus A. And this you can prove. That's your homework. Homework is prove that B minus A is that vector which starts from A and goes to B in a in the parallelogram where A and B are joined by their tail. Okay. What will you have to do for this proof? This time you will have to reverse A. because you're doing b plus minus a, right? That is your b minus a. B minus a nothing but b plus of minus a bar. So you have to reverse a, and then this will be your new parallelogram, and then this diagonal will represent b minus a, and then this diagonal and this diagonal are the same, right? I have proved it to you. I gave it to you as homework, but I only did it. But you can just do it on your own also to get proper understanding, because there will always be a difference between you watching me prove things and you proving things on your own. Because when you prove things on your own, patterns get cleared in your head. Mathematics, physics, in fact, for that matter, any other skill is all about developing the right patterns in your head. Those patterns will come when you prove things to yourself. And when you listen to me, then also you will develop patterns, but the efficiency or the accuracy of those patterns will be 50 to 60%. When you do that on your own, the accuracy and the efficiency of those patterns are going to be more than 90%, right? Can we also do this using triangle law, a minus b, the way Akshat had told? A bar minus b bar, can we get what this vector is using triangle law? We can. For that matter, if this is your vector a, right, and this is your vector b, and if you want a minus b, then what do you do? First you reverse b, then you look at this minus b. Instead of looking at this minus b, look at this guy, because to use triangle law, you have to make sure that the vectors are joined. Vectors have this orientation, tail, head. Like head and tail must be joined to use triangle law. Triangle law cannot be applied on two vectors which are joined by tails. Parallelogram law cannot be applied on two vectors which are not joined by their tails. Okay. So this is your head tail. Now you want a minus b, right? So this vector, which starts from the tail of the first vector and goes to the head of the second vector, that is going to be a minus b. And that vector and this blue vector are the same, like the second diagonal of the parallelogram. This blue and this blue are the same, so this also will be a minus b. We have proved the same thing using triangle law also. I hope you have no doubts. If you have any doubts, please let me know. Okay, and let me not call it as r bar. This is my s bar. Okay, no doubts, that's great. And you can also do b bar minus a bar using the same concept, right? This is your a bar, this is your b bar, right? You want b minus a, right? So reverse a. How do you reverse a here? You reverse a like this. This is minus a, but right now they are joined by tail. Like the vectors that you have to add, are joined by their tail. So you can't apply triangle law. How will you apply triangle law? To apply it, you will have to look at this minus a. This and this blue and brown are the same, right? And now this is tail of b, head of b. This is tail of a, head of a. Head and tail are joined. Okay, fine. Now I can use triangle law. How will I use triangle law? The vector which starts from the tail of the first vector and goes to the head of the second vector, that is my resultant vector. And in this case, my resultant, which is s bar, is going to be b bar minus a bar, because I'm adding two vectors which are b and a, right? And this green and this green are the same. So this other diagonal of the parallelogram are the same. Sir, what is the formula of triangle law? Is it the same as parallelogram law? Well, Akshat, you have seen that both these laws. Oh, okay, you're talking about that formula, the magnitude and direction formula. It is the same. Triangle law specifically does not have a formula of its own. Triangle law is only used for visualization, like to visualize where the resultant will be. But if you have to get the formula of, like, if you want the formula that can help you calculate the length of this green vector in terms of number, then you will have to use parallelogram law only, because parallelogram law helps us conveniently derive it. Okay, so then you have to make sure that your vectors are joined by the tail, and then you figure out the angle between them, theta, after joining them by the tail. That's very important, and then you can use those formulas. Okay, what is the formula for subtraction? Can somebody tell me? Can we have seen subtraction, we have visualized it, but we still haven't seen any formula. Can we quickly get the formula? In fact, without going through a very tedious derivation. We did a very tedious derivation for addition, right? Like we had a vector a bar, we had a vector b bar, there was the angle between them, these two were joined by the tail, we knew all that, and then we projected another perpendicular, then we took this triangle, then we took the bigger triangle, we did all those things to derive this formula for the resultant, and the resultant was root a square plus b square plus 2ab cos theta. Can we avoid this? Yeah, you're right, Sangeeta. Root of a square plus b square minus 2ab cos theta. But how do you derive that? You don't have to use this whole derivation again. Instead, just reverse b. Okay, this is how you do it. This is your vector a bar, capital A bar, who has a magnitude a. This is your vector b bar, which has a magnitude b. This is minus b bar, sorry, because your b bar was like that. Okay, if that was theta, then this is going to be this angle is going to be 180 minus theta, the angle between a and b, a and minus b. This is minus b bar. Okay, minus b bar whose length is b only. I made a mistake. This blue vector, in fact, let me use a different color here, or you can understand it on your own, right? This red vector is minus b bar whose length is b only, but direction is that of opposite of b. And if a and b make an angle theta, then a and minus b will make an angle of 180 minus theta. So I need the resultant s bar here. I need s bar. So I will use the same formula, but it will have a slight change. S bar is going to be root of magnitude of the first vector square, magnitude of the second vector square, plus 2ab into cos of the angle between these two. What is the angle between these two? 180 minus theta. So instead of theta, I'll have a 180 minus theta. That's all. And when it cos 180 minus theta, I don't know if you guys know from trigonometry basics, it's minus cos theta. Okay. This you will see when you study maths trigonometry basics. A square plus b square minus 2ab cos theta. This is the formula for subtraction. For addition, it's this. For subtraction, it's this. Okay. In fact, you can also find these two angles, alpha, beta. You can use instead of so let's say you need alpha, the angle that this S makes with A, right? So this is your alpha, the angle that S is making with A. So what was the formula for when these two were like this, and then when this was your alpha, what was the formula for tan alpha? It was A cos theta, sorry, A sin theta, B sin theta by A plus B cos theta, right? This was the formula by A plus B cos theta. Now your alpha is not the angle that the resultant R makes with A. Now your alpha is that angle which the resultant S makes with A. So tan alpha now is going to be, wherever you have theta, just replace that with 180 minus theta. So you have B sine of 180 minus theta by A plus B cos of 180 minus theta. Just the way, because your theta will now simply change to 180 minus theta. That is the only change that's coming, right? So I'm just replacing, using the same formula, but replacing the angle, because angle is now not theta anymore, it's 180 minus theta. So I don't know if you guys know, sine 180 minus theta is sine theta only. That's one of your trigonometry basics again that you will see. Okay, so this is nothing but B sine theta by A minus B cos theta. Likewise, if you need this beta, then alpha plus beta is going to be theta. So you can get beta by using theta minus tan inverse B sine theta by A minus B cos theta. Do not get scared by looking at these formulas, guys. I'm not asking you to remember them. We have got them by proper derivation concepts. Okay. So this is how you get your beta. This is your tan alpha's formula. And these two are in case of subtraction. I'm subtracting them, subtracting A and B. Tan alpha's formula and beta's formula were different when we were adding them, because there we were not using 180 minus theta, where there we were using theta, right? So with this we finish subtraction of two vectors. Tomorrow first we will discuss a few problems, very quickly. Very quickly we will see how we can add, subtract two vectors, get the angles between them. Then we will discuss another law, third law, that is Polygon Law of Addition. These three laws are enough. Once you know addition law, once you know parallelogram law, once you know triangle law, and third is once you know polygon law. Polygon law is even more simple. Then all laws for addition subtraction are done. Then we will move into components of a vector. So interesting stuff coming up, guys. Make sure that you are live, right? Because if you are not live, then you will have to see all this in a recorded form. And then if you get any doubt, the way Sangeeta got a doubt in the middle of the session, that sir, what is the difference between triangle law and parallelogram law? If you get such doubts while watching a recorded lecture, you will have no one to ask to. Even if you reply it in the comments, you will not get an instant reply. It's always better to get an instant reply for a doubt that you have in real time. And that can only happen if you are live. So make sure that you keep coming live. Even if you need some revision, fine. After this live session, go back, watch the previous videos, do your revision, and then come. Okay. Come to attend. Junaid Ahmed has just come. He's asking, what is this about? Well, Junaid, you can watch the first video. Like, there is a video on this channel called as the Introduction to Bridge course. That will clearly explain you what this bridge course is all about and what we are doing here. Watch that. And if you want to join with us and continue studying, then watch the videos from Saturday at least. Okay, watch this video introduction and then watch videos from last Saturday at least. There are videos before that also, but we have started vectors from last Saturday. So start watching that and then make sure that you are up with the class from tomorrow. But yeah, if those of you who are coming live, you will really be benefited, much more than people who are watching recorded lectures and are not sitting live with me. So with this, I would like to end today. Thank you for having me. It's time. And we will meet tomorrow with a few more interesting topics. Thank you guys. Take care. Stay safe. Bye.